is an extremely strong metal made by combining iron with a little bit of carbon. This combo makes it tougher than just iron or carbon on its own. Because it's so strong, especially when being pulled or squished, steel is great for things like bridges, buildings, and cars. When we think about the future, steel is a major component. Scientists, architects, and creators are harnessing their skills and collaborating to build out of this world extremely strong buildings, bridges, and infrastructure that will be efficient and resilient. Already, steel is being used to build structures that are stronger than ever to resist wind and weather events, support for solar panel frames, and be recycled over and over again for new use.
Wow.
Today, we'll meet with people who are already looking to the future and examining challenges and opportunities facing our world. We'll visit teams of STEM champions to find out how they are dreaming up incredible ways to innovate with steel. Together, we'll forge into the future. Join me on this Forging Innovation Mission Possible virtual field trip, a partnership between Discovery Education and Nucor. Say steel! While technology and innovation is always shaping our world, when we find something that works, we're able to think about new ways to put it to use, like steel. You must be Luke.
I am.
Sounds like you're the steel deal. So where are we right now?
We are actually in downtown Chicago, and we are on the Lake Street Bridge, which is one of 37 bridges that actually are located in the city of Chicago that are operable, meaning they can open and close.
Sounds like steel makes a lot of things possible, including your job. What exactly do you do and how do you work with steel?
So I actually work at a company called Nucor. We are the largest steel producer in the United States. And then we also make many other things like joists and decking or even bolts that can go into buildings.
So what I want to know is how has steel shaped our past and how is it building our future?
So steel has actually been around for thousands of years, and really it's something that makes our modern economy and everything possible.
Is steel a naturally occurring metal?
It actually is not, but steel is predominantly made from iron. So if you take existing iron ore out of the ground, that's the predominant material. Then there's other things that go into it like alloys. So there are different grades of steel. So steel that would go into a building versus into a car, that's a different grade of steel, meaning that there's different levels of other metals that you put into that to help achieve those different strengths of steel and grades of steel.
How was steel made in the past and how is it being made today?
So steel in the past has been made in many different ways. The most common method actually was invented about 1,000 years ago, and that was in a blast furnace. So what you do is they take a lot of iron ore, other virgin materials, and bring that into that process. The funny thing is that that process wasn't actually patented until the early 19th century, so it had been around for a long time. The way that Nucor makes steel is in an electric arc furnace, and what that is we take existing pieces of steel, so think of old cars, old pieces of buildings, old appliances, and we actually melt those pieces of steel with electricity, and we make brand new steel. And that process can actually happen over and over and over again. And steel is also nearly 100% recyclable.
So even old steel can get a brand new life?
Yes, exactly.
So how many different ways can steel be used once it's made?
Steel is actually used in many ways. It can be something that is found in your refrigerator in your house, the bus that you ride to school in, this bridge that we're walking across, as well as many of these buildings that we see around us right now.
It's a lot of uses. So how has steel evolved over time?
I would say one of the major changes is that steel has become much stronger. So steel that was even made about 100 years ago, the steel of today is probably almost twice as strong as steel that was made then. That's one major improvement, which also means you can use less steel to accomplish the same thing. In addition, the process has become overall much more efficient. So we use less man hours to create steel. The quality of steel has improved, so there's just been a lot of major changes that have driven the quality and process of how we make steel.
Wow, so it sounds like the ideas you were talking about take a lot of teamwork and planning to make them happen. I'm interested in seeing how we're using steel today to make futuristic buildings.
Well, why don't you beam yourself over to 150 North Riverside and meet up with Dave? And you can learn about how steel isn't just strong, it's sky high, way high. Get ready to look up.
Okay. I'm here with structural engineer and architect Dave Ekman, and he's gonna help us see the city in a whole new way through steel. What's going on with this building behind us, Dave? I mean, it looks like it's on tiptoes.
Well, this project was really exciting to be a part of. The challenge for this particular building was that the site was only 85 feet wide, yet the owner wanted a building that was 130 feet wide, so it was too big for the site. So what we came up with was an idea with the architects to taper the bottom of the building so that none of the steel columns go down to the ground, but they actually slope into the central core.
Wow, that's pretty unique, and it looks really cool as well. So Dave, how does steel make a building like this possible?
Steel is really the best choice for a building like this, primarily because the edges of the building can't touch the ground. And so with steel, it's like an erector set where you can bring out beams and columns and just bolt them and weld them together and attach it to the center core of this building.
So the steel in this building is different than the steel we see in our refrigerators and washing machines at home, right?
Absolutely. It's much stronger steel. And actually in this building, we were using something called grade 70 steel for some of the columns. And that was some of the strongest steel that was available. And this is the first application of grade 70 steel in the United States.
So would creating a building like this be possible without steel?
Steel is the most logical choice for this particular building. Other materials, you would need shoring and formwork and things like that that just wouldn't be possible.
Okay, Dave, let's continue the steel speed tour.
Okay, let's go.
Up next is Aqua Tower. This building looks like it's made out of mostly concrete. What's the steel connection?
Well, I say that steel in this building is the hidden Superman, because while the outside is concrete, there is steel inside of every floor and wall of this building. It's different that it's not wide flanges like some of the other buildings we've looked at, but this is steel reinforcing bars, otherwise known as rebar. While concrete is really strong in compression, if you step on it or squeeze it, it's not particularly strong if you had a concrete beam and you try to bend it or you try to pull it in tension. But the steel inside of that concrete provides it the tension and allows it to do the things that you want it to do. So for example, all these balconies, they're called cantilevers. And a cantilever is basically just a span that only has a support on one end, like a diving board. It wouldn't be possible without the steel inside, otherwise the balconies would just break off. So steel is the only thing that allows this particular building to exist in the way that it does.
Up next is the Radnor Athletic Center. This one looks like it's floating in midair. So what exactly is holding this place up?
The building looks like it's floating, or the roof anyway, right? And that's partially because it is. So inside is a gymnasium. There's actually 2 basketball courts in there. And in another area, there's an Olympic-sized pool. The architect wanted to have long spans, obviously, because you can't have columns coming down in the basketball court or in the pool. But he also wanted the roof profile to be very thin. So what we did is, instead of having the supports from below the roof, we said, what if we support it from above? Which is exactly what we have. We've got some steel cables that grab the top of the roof, and then that brings the loads back down to the ground.
Okay, time to talk future. Some of these designs look like they're straight out of a sci-fi movie. Twisting towers, moving parts, even steel shaped like tree branches. Are all of these things really possible with steel?
Absolutely. Steel's an amazing material. It can be stretched, it can be bent, it can be twisted. And right now we're starting to look at something where 3D printing with structural steel.
Are there any cool projects that you've seen or worked on that use this new technique?
Well, funny you should ask, because we just put together a pedestrian bridge. So we came up with a site, like, where would you find a pedestrian bridge? Well, many times you might find it in the woods, going across a creek or a river. So we used that theme to design the bridge. And so we use steel to represent things within nature, like specifically trees in the woods or reeds or grasses that you would find in the woods. But the printing process is amazingly quick. Once we know how thick it needs to be and what the shape needs to be, you're just running a program to a robot, and the robot can print out something like these pieces in only a few days.
Super quick.
Yeah, it is. It's exciting.
What advice do you have for young people who love to design, build, and dream big?
Well, I would say keep dreaming big. The possibilities out there are incredible. Always ask the question why, and make our world a better place.
Sounds good. I'm looking forward to see what the future has in store. Wow, my mind is blown. If you're into art, tech, buildings, or problem solving, this might be the future for you. Thanks so much for showing us around, Dave.
And thanks for visiting.
These piles behind me may look like junk, but there are actually tons of steel scrap from things we throw away, like old cars, washing machines, even bicycles like you may have at home. And eventually, all this becomes this. New steel used to create all new things. Behind this transformation is some serious brain power. Today, we're meeting two awesome engineers, Jojo and Sophie, who use science to make it happen. Let's go find out how they help turn scrap into steel, and steel into, well, everything. Hi Jojo, hi Sophie.
Hi, nice to meet you. Welcome to Hertford County.
I'm super excited to see what you guys do here.
We're excited to have you. Let's go. So this is the electric arc furnace, otherwise known as the EAF. Jeff is currently melting heat of scrap, which is somewhere around 150 tons of scrap metal that he's turning from a solid into a liquid.
How much steel do you guys produce in like a day?
We're producing about 5,000 tons in a 24-hour period.
And like heating the steel that hot must take a lot of energy.
It does take quite a bit of energy. The cool part about our furnace is that it's mainly electrical energy. We also use some chemical energy. So some of the reactions happening right now inside the furnace are happening between oxygen, carbon, and everything else that's in the scrap itself.
What is a chemical reaction and how is it involved in the steel making process?
A chemical reaction is basically any time that the chemical structure of a material changes. We're adding a ton of oxygen and carbon, and lots of chemical reactions are happening to change the structure.
This all seems really complicated.
It's part science, part magic, and I think that's what we love about it.
Where are we going next?
So our next stop is the ladle metallurgical furnace, otherwise known as the LMF.
Come on guys, let's go.
Woo. So now we're at the LMF. We're getting the time, the temperature, the chemistry perfect before we make that liquid back into a solid.
Are we adding anything to the liquid here?
We sure are. What are some of the things we're adding right now, Sophie?
Well, we're gonna add a lot of carbon. We're gonna add calcium, we're gonna add silicon, manganese, and a whole load of other elements, even nickel and chromium.
Does adding that stuff make the steel stronger?
It definitely can. Iron on its own is pretty brittle, so when you add things like carbon and other elements, it can make the steel more durable. It'll bend instead of just snapping.
You two are the perfect people to help me melt down some myths about steel. Are you ready for a fast-paced question and answer round?
Heck yeah, bring it on.
Yeah, we won't melt under pressure.
Okay, put 60 seconds on the clock and I have the questions right here. First, does steel go to waste once a building or railroad is no longer needed?
So steel is infinitely recyclable, which means that the steel that was in a bridge 200 years ago can be the steel that's in a skyscraper 200 years from now.
Wow, that's super cool. Next, does modern steel still come out strong?
Oh yeah, stronger than ever. We're always making improvements.
Nice. True or false? Steel is so heavy, it can't be used in things that need to be lightweight.
False. There are so many different grades of steel. In fact, at this facility alone, we make over 300 grades of steel. So we're constantly trying to make it stronger and lighter.
Wow. Next, is steel still made today the way it was made 100 years ago?
Absolutely not. We have so many new technologies, it's much more efficient.
Okay. And last question, is steel a thing of the past or crucial to the future?
I would say it's both. I think it was an important part of our past, and it's also a bridge to our future.
Wow, I think we made it under 60 seconds.
Wow.
Great job, guys.
Awesome.
Sounds like there are all kinds of high-tech jobs in steel production to make it stronger and more sustainable than ever. But now it's time to roll on, like a freshly milled steel plate. Let's go meet Jorge.
Whoa, is this a steel mill or a video game control center? These screens, the buttons, the joysticks, I feel like I just leveled up into Steel Ops Pro. I'm here with Jorge to learn more about what's going on here. Hey Jorge.
Hey Vashti.
So do you work with these machines?
I actually do. My function is to do the software development part. We have operators that run the machines, but we do all the software, we do all the interfaces, so when they press a button, the machine performs.
Do you know what these buttons or even the joysticks do?
Yes, we have automated cranes that run on their own, but sometimes those cranes need manual adjustments. From this area, the operators can take the joysticks, press the buttons, and they can control the cranes using all the cameras that we have installed.
So it kind of is like a video game, but with real cranes.
The reason we do this is they no longer have to be outside. They can control everything from in here in a safe manner.
So what's an example of how automation is used to help keep people safe?
So to keep people safe, we have different types of technologies. So we use such things as interlock. So when a machine is going to do something, we have sensors that will detect if a human presence is there, and it will stop. It will not let the machine run to make sure that our teammates are kept safe. So that's the robot right there. So the robot, what it does, is going to turn, it's going to go into the ladle, grab a sample. If you look around the robot, all that fencing, if anybody opens any of those doors, it'll stop the robot, it'll stop everything.
So I've heard this term digital twin. What exactly is a digital twin?
So a digital twin is a virtual representation of physical objects. So what we do is we connect all these automation sensors that we install, we connect them to a virtual world. So we're able to collect all this data. And with all this data, we use advanced machine learning and AI models to be able to predict failures. So instead of doing reactive maintenance, you can do predictive maintenance. So this helps us to be able to keep running continuously.
So this is the scrapyard.
Yes, this is the scrapyard of our mill. We have a remote push loader that pushes the material in, and in the control center where we were at, the operators can monitor the crane from there. If they have to do any manual interaction, and those joysticks that you saw in the control center, that's where they can operate from if they need to.
Wow, so like there's no one in the cab of that crane at all.
That is correct. If you see, we try to keep our scrapyard free of people so that we can have our teammates out of harm's way. So everything is done from the remote pulpit.
That's amazing.
Well, Vashti, welcome to my office.
Wow, this is a lot of screens.
That actually is. So if you remember all the screens that we saw, a lot of them are visible here where I can capture all the data here. So with all that information, we can eventually get to artificial intelligence. So the artificial intelligence can say, hey, be careful because this is going to happen before it actually happens. Because AI is able to process information faster than us humans.
So this is pretty cool. Did you help like make this mock-up with your data?
Yeah, all of this is built up off of the data that we're using. It takes days, it takes hours of data collection, of data processing to analyze how you want it to come out to be and what it needs to be.
So for the students watching who are interested in doing things like this, what kind of education would they need?
You can study computer science, engineering, mechatronics, because school will give you the fundamentals, but it depends on you, on the person or on the student that wants to go above and beyond.
So what's your favorite part of your job?
After you're working on a code or on a project or coding it after several hours, when you get it to work and it helps keep our teammates safe, that's the best part of the job.
Okay, so what about the future? Like 100 years from now, what will AI allow us to create? I'm dreaming of a super tall skyscraper that spirals all the way to the top with a huge slide. Is that possible?
Anything is possible if you have the correct tools and the correct AI.
What if we added a snack dispenser in case I forgot lunch?
We can even do that too. Make sure you're not hungry.
Okay, I'm wired for the future and all the careers that students can explore. Until today, I didn't know steel would be such a big part of the future of innovation.
For sure, steel is essential for building a sustainable world.
Thank you so much for allowing me to tag along and be a steel superhero today. It was so much fun.
I'm glad you enjoyed it. You're welcome anytime.
Today, we learned the value of steel throughout history and how it's been used to innovate. We visited a revolutionary skyscraper, saw renderings of how structures might look in the future, melted down myths about steel, and we visited a modern steel mill equipped with new technology, robotics, and AI to see how steel has made all these amazing projects possible. From skyscrapers to sports stadiums, roller coasters to robots, steel is everywhere, and it's always evolving. The coolest part? You can be part of what comes next. Whether you're into tech, teamwork, designing, building, or even gaming. Remember that control room? There are careers waiting for all kinds of passions in the world of steel. You just might design the next self-healing skyscraper, or revolutionize our lives as we know them with a floating steel city. It will take builders, designers, architects, engineers, and even roles that haven't been created yet, working alongside AI to make it all happen. So, keep asking questions, keep exploring, and check out our website to learn more, because the future of steel might just be in your hands. Until next time, forge ahead and keep dreaming big. Bye!